Hello and welcome back to another HTH 2021 CTF solve video. In this video, we're going to be taking a look at the first cryptography video or crypto challenge video. And we're going to take a look at the arrival. So this one was a little bit harder than anticipated with only 10 solves. In this video or this challenge, what we had to do was connect to this service and try to figure out what the flag was. So let's connect and see what it ends up giving us. So here we're given key 1, and then we're given key 2 and 1 XOR together, key 2 and 3 XOR together, then finally the flag XOR with key 1, 3, and 2. So there's some things we need to know about XOR before we attempt to approach this problem. I'm going to go ahead and copy this stuff. And the challenge also had this file called XOR Properties attached to it, which I've already downloaded and I have here. We're going to go ahead and run that XOR challenge. I'm going to show you what it actually, the XOR properties file, and show you what it spits out. So it says it's checking 4 different properties to see whether or not they hold. Those are XOR properties, and those properties are commutative, associative, identity, and self-inverse. So let's take a look at what that actually means. So first of all, just like I said, if I were to say, what's 5 plus 1? It's 6. Now, what's 1 plus 5? Doesn't matter. It's still 6, right? It's the same thing with XOR. It doesn't matter which way that you're XORing two unique things. They're going to come out with the same result. So if we move down here and we had 3 different things, it's associative in that it doesn't matter which order you first XOR the first 2 things and then the second thing. So if I said, what's 1 plus 2 plus 3, it doesn't matter if you add 1 and 3 or 2 and 1 or 2 and 3 together first, you're going to come out with the same answer every single time. And that's what associative is telling us. The identity means that if we take anything XORed with 0, we just get that anything. So 5 XOR 0 is 5. 270,000 XOR 0 is 270,000. It's that simple. And finally, the self-inverse is whatever you take, XOR itself ends up being 0. So 5 XOR 5 is 0. 5 million XOR 5 million is 0. And that's the properties that this is going through. It's using the assert, which means that we have some assertion about what a product or a value, a result should be. And if that ever fails, we need to raise an exception. The exception is called an assertion error. And then we print something out. So let's say I flipped this logic around on accident and I reran this. It should tell us the commutative property does not hold. It raised an exception and we handled it by printing out a specific message. So in this case, all of the properties originally came out as they hold. Okay. All right. So now how do we use this thing with what we were given when we connected to the challenge? First of all, we have these and I want to format them in a way that sort of makes sense. So I'm going to say key 1 and then I'll put this stuff here. So I don't have key 2 or 3 yet. And then I want the flag. Right. So key 1 we do totally have. We don't have key 2, but we do have key 2, key 1. Right. This is very important. So this is key 1 and 2 XOR together. Now there's a certain property that's going to help us retrieve key 2, and that is going to be the self-inverse property. Okay. So if I have key 1, key 2, I can XOR it with key 1, and that's going to remove key 1 from that combination and leave us only with key 2. If you've seen, there's some really good videos on YouTube and online about certain cryptographic primitives and cryptography algorithms. What's interesting is they sort of explain it like paint, right? So you take a hue of blue, a hue of red, and you mix them together. And what you get is a final result that's really difficult to extract or take apart those 2 things, right? So if you take different colors of paint and you mix them together, good luck getting those apart. Those are the type of cryptographic properties that we really want in modern cryptography. But with XOR, it's really interesting in that it's almost like taking red and blue color balls and throwing them into a big bin. It's very easy to pluck those things out and reseparate them, right? That's sort of what we're doing here in the sense that these properties are very easy to sort of undo what you've already done, but they have the very interesting properties that build on each other and help us with modern cryptography. So that's why this challenge is actually important. All right, so we have key 2, 1, and then we have key 2, 3. Let's go ahead and get that. This is all part of the setup for trying to solve this guy. And then we have flag. key1. Whoops. And what we want to do is slowly isolate that flag. key3, key2. Okay. And we want to get these missing things here. So these three are what we need to get. So let's go ahead and get them. All right, copy this out. We have all of our knowns. And what we do is we'll go ahead and take a look at how we use this in checking for the properties. First of all, we do is bin ASCII hexlify. Bin ASCII is something that helps us with binary ASCII. So the ASCII representation, dead beef, if I want that to be in binary form, I use unhexlify. If I had something that's already in binary form and I want to print it out nice, so let's say I opened a socket in Python and I read raw bytes coming across and I wanted to print them out in ASCII, I could do bin ASCII hexlify and it does the formatting for me. So that's why bin ASCII is very important. But we have this thing called XOR byte string, which will take these, convert them to the right view or the right format, and then give them to us. So for key 2, I know that I'm going to want to take key 2 XOR key 1 and XOR it with key 1 to remove key 1 from key 2 via the self-inverse property. All right, so let's do this. So we got key 1 and then key 2 1. And again, it doesn't matter which way I provide these as inputs. And that's because the commutative property tells us that that is the case. It doesn't matter which way I put these. All right, so let's go up here. I'll rerun this again. And it's telling us that there are type errors, so these can't be strings. Again, up here, we're going to format these with bin ASCII unhexlify. I think I'm going to go ahead and just put those up here. I don't have to keep doing it when I pass it to every XOR byte string. So let's go here. Then if I run this, we should be good. Okay, all that stuff runs. I'm going to go ahead and just comment this stuff out so I don't have to see that every time I run it. And then we're going to do key 3. So key 3 is just needs to be sort of unmixed with key 2. So if I take our key 2 3, right, so we'll go key 2 3, and then I'm going to try to remove key 2, which we got previously. I'm going to put that in there. We should be good, hopefully. All right, everything worked there. And now I'm going to go and get the flag. So to do this, I'm going to take this whole thing. First of all, here, all of this, and I actually need to break this up into multiple parts. Okay, so I'm going to do the first part as A, second part as B, and then I'll do the third part as C, and I'll kind of show you what this means here. Because this function only takes 2 inputs, we need to break this apart. And breaking apart is going to kind of help us show the associative property. So here I have my first part, which is going to be this guy, and I'm going to remove flat or key 1. So I have this whole thing. Let's remove key 1. Key 1. Now we're going to be left with the flag. I guess I can kind of spell this out a little bit more. Flag key 3, key 2. Okay. Then what we're going to do is do flag key 3 by getting rid of from here. I'm going to be getting rid of key 3. So let's, sorry, key 2. So let's get rid of key 2 here. That will get rid of key 2. And then finally, we're going to be left with the flag once we remove key 3. So I'm going to take this guy here and then give it key 3. And we're going to get the flag and we're going to print it. I think I'm going to have to do something on the output here to print that nicely. Oh, no, it just gave us to us. Okay, so this is a binary string. I can do something like encode UTF-8 to give me just the normal string, but Python does a good job in just showing it to us. So this is sort of like unmixing. We're taking a basket, in this case of key 2 and key 1. We're sort of taking like ping pong balls that have key 1 and key 2 on them, and we're mixing them all together, and we're saying, I want to remove key 1 from the key 2, key 1 mixture, and we go through and start looking at them, and every time we see a key 1, we just throw it away, and we do that until we're finally left with nothing but key 2s. Then we continue that process by pulling out things using that self-inverse property that's saying that if this and this both exist, we just remove them. It's really cool and fascinating, almost seems like magic at some point, but this is a very important part of cryptography, and we'll see that kind of pop up in the next couple of challenges. So I'll pop this in here, submit, and that's the correct flag. Next challenge we'll do come out to play. Until then, thanks for watching.